Welcome back to Madam YY channel. Today I'm going to discuss two types of covalent bond cleavage in organic compounds such as homolytic cleavage and heterolytic cleavage. Homolytic cleavage occurs in a non-polar bond involving two atoms of similar electronegativity. So a single bond breaks symmetrically into two equal parts, leaving each atom with one unpaired electrons. So the atom with one unpaired electron is called a free radical. Let's look at how homolytic cleavage happens in the X molecule. So X molecule have the similar electronegativity between the X atom. In the presence of ultra UV light, typically sunlight, the single bond between the X atom will break evenly, leaving each of the X atom with one unpaired electron. So this is a free radicals. So how can we write the equation? It will be UV, and then when the single bond is break, we will use a half-headed arrow to show that each electron is given to the X atom. So this is a half-headed arrow, show one atom will be given to the X atom. So we will get two X free radicals. Homolytic cleavage happens in a polar molecule involving unequal sharing of electron pair between two atoms of different electronegativities. So a single bond breaks unsymmetrically. The bonding electrons will be transferred to the more electronegative atom. So cation and anion will form. So based on this diagram, I have a AB molecule. So what happened is B molecule is more electronegative than A molecule. So when the heterolytic cleavage happens, both the electrons will be transferred to B atoms. So the A will become a positive ion and the B gain 2 electrons, so it will become a negative ion. So the cation and anion is formed in the process of heterolytic cleavage. Here are more examples of homolytic cleavage happen in the chlorine molecule. So both chlorine atoms are having the same electronegativity. So in the presence of UV light, a single bond will break symmetrically. So each of the electron will be given to the chlorine atom. So you can see a half-headed arrow show that one electron is transferred to the atom. So we will be having chlorine free radicals. And for ethane, the carbon is having the same electronegativities. So when homolytic cleavage happens, each atom will be given to the carbon atom. So we will form the free radicals. However, in heterolytic cleavage, it happens in atoms of different electronegativity. So for hydrogen bromide, when a single electron is break, both the electrons are transferred to the bromine because bromine is more electronegative than hydrogen. So this will form hydrogen ions and the bromide ions, which is cation and anion. And next one, we have 2-chloro-2-methylpropane. So between the carbon and chlorine, chlorine is more electronegative than carbon. So when heterolytic cleavage happens, the both electron from the single bond will be given to chlorine atom. So you can see a full-headed arrow is used to show the transfer of 2 electrons. So when 2 electron is given to chlorine, it will form a Cl minus anion, and we will have the cation form. So the difference between homolytic cleavage and heterolytic cleavage is homolytic cleavage must happen in the presence of UV light. However, homolytic cleavage does not need the presence of UV light. And the arrow used, one is half-headed, and heterolytic cleavage we are using a full-headed arrow. So this arrow is used to show the process of reaction where reactant is converted into product, and half and full-headed arrow is used to show the movement of an electron pair, which means that 2 electrons. And a half-headed arrow is used to show the movement of a single electron. Alright, next let's try the questions. Can you use the arrow to show the movement of electrons in each reaction? So question 1, I have a free radicals formed, and the reaction happen between 2 oxygen atoms which have the similar electronegativity. So this is my homolytic cleavage reaction. So a half-headed arrow will be used to show the movement of 1 electron to each oxygen atom. And second questions, my product form are free radicals. So I have a carbon free radicals and a HCl. So when you have free radical forms, normally it involves the homolytic cleavage. So we will be using the half-headed arrow. So the reaction will be happen between the CH, where the single bond is break symmetrically. So 1 electron is given to carbon and another electrons will be given to the hydrogen, where it will combine with another electron from chlorine to form into HCl. So there's a single bond formed by 1 electron from hydrogen and 1 electron from chlorine. So a HCl single bond is formed. And the question C, so based on the question C, I have a carbon anion, carbanion, and a X positive ion, okay, and a cation. So when you have cation and an ion forms, normally it will involve the heterolytic cleavage. So the negative charge is on the carbon. It means that both the electrons are transferred to the carbon when the single bond is broken.